I'm going to teach you guys how to solve projectile motion using vectors and uniform acceleration. Alright, the problem I'm choosing to teach you with projectile motion with is a horizontal projectile path. Okay, so a cat chases a mouse across a 2.3 meter high table. The mouse steps out of the way and the cat slides off the table and strikes the floor 2.8 meters from the edge of the table. What was the cat's speed when it slid off the table? The acceleration of gravity is 9.81 meters per second squared. Answer in units of meters per second. First off, I'm going to tell you the basics about projectile motion. Projectile motion is solved using vector quantities and uniform acceleration. Vector quantities being made up of x and y components, which we use to find initial velocity, and we will use the uniform acceleration to solve for time, displacement, and so on. Knowing that the path of the cat starting horizontal, the initial velocity for the y component is going to be 0 meters per second. The angle represented by theta, it won't be necessary for this problem, but will be for other cases. Now, we need to draw a diagram, a picture for this problem. Okay, now let's figure out what we're trying to solve for, which is the initial velocity for the x component. Next, let's draw a vector for the initial velocity, and represented horizontal, vertical, and the actual component. Now that we have these set up, now we can list what we already know, breaking it up into x and y components, following uniform acceleration rules. And time is going to be equal because they share the same time, and we know that the displacement for y is going to be negative. First, we need to find the time it takes for the cat to hit the floor. We are going to solve for time on the y component side. To avoid quadratic formula, I'm going to find the final velocity and then solve for time because the time for x and y are equal. And if you follow my steps, I cancel out the vi squared because it's 0 meters per second, and then I just plug in my numbers to get v of f of y, and it's going to be negative since the cat is going down. And then I plug it into this equation, canceling out y again, and then I solve for my time. And just using your numbers, and this one's going to be positive because... Okay, now that you have the time, you could plug it in for the x, and you're going to want to use this equation, which is d equals vit plus 1 half at squared. But the 1 half at squared, you get to cancel it out because the 0 meters per second cancel it out, which would leave you with d of vit. Then you rearrange it with vi alone, and vi equals dit. Now that we have vix, now that we're trying to solve for vix, we're going to just plug in our numbers using that equation, and then we find our initial velocity for x, and that is your final answer. Thank you for watching.